Good morning, boys. Welcome to online class, and I'm your teacher Jana Akhtar is with you. We just had some discussion on our previous classes. We had discussed about some creative type questions, and the more and more you practice creative type question, you will have good command over your book, over your syllabus, and you will have a very good marks on your exam. And as we have reviewed the chapters already, and now our main focus is to practice different types of creative questions from all the chapters. So let's start the class. Today I will try to discuss another math from current electricity. Actually, this is a mixture from current electricity and magnetic effects of current, because this is a question which has a transformer and the circuit part also. The first here in this 10 there are two diagrams. First one is related to transformer and second one is a circuit. In the transformer based diagram, that means in first diagram, the number of turns in primary winding is 500 and in secondary winding is 1800, and primary voltage is 220 volt. These are the information for first figure. And in second diagram there are some combination of some resistance. Five resistance are used here, given here, and the two keys are also given here, and a voltage source is also used here. According to this diagram, what are the questions? First one is what is electric lines of force? Electric lines are imaginary lines, and actually these are the path of free positive charge in an electric field, and these are imaginary lines. Second one is explain the value of electromotive force is always greater than potential difference of a closed circuit. For a closed circuit, you know the definition of electromotive force. What is electromotive force? Actually, this is the work done by the source in driving a unit positive charge that starts from the one end of a circuit and it comes back to the same point by traveling the complete circuit along with the source. So that total work done is called electromotive force. But potential difference is this is also work done, but this is the work done for moving a positive unit charge from any specific point of a circuit to another point. So this work done is smaller than the work done in work done for electromotive force. That's why the value of electromotive force is always greater than the value of potential difference. Now question number C, find the output of figure 1. That means transformer based figure. Output means here as in input the voltage source or primary voltage is given to 20 volt. Output means we have to measure the voltage for secondary, that means Vs. And as we know, voltage and number of turns in for a transformer are proportional, so we can write Vp by Vs equals Np divided by Ns, and from this equation we can easily measure the value of output, that means the value of voltage of secondary winding, that is Vs is equals after calculation it will be 792 volt. So this is a very easy one. The question number C, the output of figure, that means the output of secondary winding, that is secondary voltage, and we have got the answer here is 792 volt. So now for question number D, let's have a look on it. The question number D is how much time the electric current will change in R5 if K2, that means the key 2 remains open and closed. If we just remain the K2 remain open and then closed, what will be the change in current across R5, across the resistance 5, that means 8 ohm. We have to calculate that one. So let's try to solve this question. We will try to solve this question in some different parts. First of all, we will consider the key 2 is opened. That means key 2 will not active in the circuit. On that case, if we just see the circuit over here, on that case, this path of 4 ohm, this path of 4 ohm will be inactive in the circuit as the key 2 is opened over here, so this will not act on the circuit. So on that case, the circuit will just be in the form like this one, and from this we can just calculate the resistors over here, the combination of resistors here, and we can simplify the circuit in this form. And finally, here are 4 resistances here, 8 ohm, 4 ohm. These 2 resistors are in parallel, and another 2 resistors are in series, 8 ohm. And finally, we get the equivalent resistance for this circuit. When the K2 remains open, the equivalent circuit will be 18.67 ohm. So as we have got the equivalent circuit, now we can easily measure the circuit current, total current, and that will be according to Ohm's law. I1 equals V divided by RT, and we will get the value over here 11.78 amps. But in our question, it was mentioned that we have to calculate the current across R5. As we can see from here, R5 means 8 ohm. We can see here on this diagram, the after simplifying the circuit, we just get a simple series combination of 3 resistors, and whenever some resistors are in series, they will possess same amount of current as they are in series. That will be just equal to the circuit main current. So here main current is 11.78 ohm, and as these trees are in series, so every resistors will just have current 11.78 ohm. So we can see from this point that the resistor R5, the current across the resistor R5 will be 11.78 amps. This is the current when K2 remains open. Now we will see when K2 is closed, what changes comes over here. If K2 is closed, on that case, this one will be active also. That means this portion of the circuit will act now, and we have to consider it now. So if we just simplify the circuit, what is the difference between with the previous circuit? The difference only here is that with the previous one, here 4 ohm resistor will be in parallel with this combination. That means here we just get the change in total resistance of the circuit, or combination of resistance of the circuit, or equivalent resistance of the circuit. And if we just calculate or simplify the circuit in 2 or 3 stages, we will get the equivalent resistance here 2.0909 for this combination. And after adding the 8 ohm in, as this is in series with 2.909, so after adding these 2 resistors, finally we get the total resistance of the circuit, or equivalent resistance of the circuit, 10.909. Actually you have to keep in mind one thing. There is no internal resistance mentioned in the circuit. That means the battery here for battery there is no internal resistance is given, but if the internal resistance is mentioned on the question, then you have to calculate that one. So finally we have got the internal resistance for second condition is 10.909, and from these we just calculate the current I2. I2 means when the key 2 is closed, on that situation the current here is I2. So I2 is equals, we will get the current 20.16 amps. And then if we want to make a compare between I1 and I2, then we just see that I2 is equals 1.71 times of I1, and that is the desired solution. That in our question it was mentioned that how much time the current will be for R5 if once it is remained open and once it is remained closed. So we are observing that whenever the K2 is closed, then the current is more than when the key 1 remains opened. So here is another observation that when key 2 is closed, that means the resistance of the total resistance of the circuit is reduced over here, and that's why we have got more current on the in the second case. So this is the solution of the given questions, and I think if you just practice this type of question, you will be able to solve all types of problems related to different chapters. And as I have told earlier to you that chapter 11, chapter 12, chapter 6, some chapters are there in your book. The questions are must from these chapters, so you just try to practice more and more CQ type question from these chapters. And in last class I just gave you homework. Try to submit it as early as possible, and that's all for now. We will just try to discuss some other creative type questions on our next class, and take care, have a good time. Goodbye for now.